Hello, everybody. I'm Alexey Krabarov. I'm the AI Commit Architect at Neo4j, and I'm on a big trip of Europe. I just went to FOSDEM in Brussels and Ghent and JFocus in Stockholm, and now I'm here at Hugging Face in Paris with Eric Kaunismäki, who is a software engineer working on inference.
Yeah.
So thanks for hosting me. It's super fun to be at Hugging Face office finally. One of the top hubs of community open source AI. So what are you working on at Hugging Face?
Yeah, so I'm basically working on our internal inference product called Inference Endpoints.
Mm-hmm.
So it's a hosted platform where people can basically, let's say you have your model on the Hugging Face hub and you can quickly deploy it on NVIDIA hardware, on AWS inferential chips, very seamlessly, very easy. And that's kind of like what I'm working on.
So for folks who don't know the guts and internals of AI, why is inference hard and how is it different from training and why do people need to work on inference especially?
Yeah, I'd say like in general, because they're completely different paradigms.
Mm-hmm.
So training, you want to be flexible, you want to, let's say, implement quickly ideas from papers, you want to try out new things, see how they pan out.
Mm-hmm.
So you want to be very flexible and try new things. Whereas when you go to inference, you have the completely opposite paradigm. You know what your model architecture looks like, you kind of like know where you want to go. So it's kind of like even thinking like from these two principles, even the choice of programming language would be different. So like training, really nice to be in Python where you can change things up quickly. Whereas in inference, you'd rather maybe do it in a lower level language where you actually have control over memory, say, for example, with Rust or something like that, Rust or C++. And then usually when you go to inference, we're talking about then it's like a product. Whereas in training, you're still doing research.
Mm-hmm.
So those two also have very different requirements and requires you to think about things very differently.
Right, and so when you go to Hugging Face and you download the model,
Yeah.
right? So that model, is it ready to run on different kinds of hardware or does it need to be specialized for different GPUs?
Yeah, in reality, let's say like you just download it on your own machine, most likely there's going to be some rough edges to uncover, and that's kind of like what we're trying to do with the inference endpoints. That is like we try to uncover those sharp edges for you, so that when you kind of like deploy it on a specific hardware through our inference endpoints, it's actually like a one-click solution. So yeah, I'd like to see a world in the future where you could actually download and everything works seamlessly out of the box. But the AI field is just like changing so much constantly that it's like chasing a moving target.
So if you kind of double click on this a little bit, right? So I'm curious, as a software engineer, right? I'm an application engineer, so I'm on top of the stack, right? I think about knowledge and like things, and like you're actually making this stuff happen. So the model is trained, let's say, is a PyTorch model, right? And it's trained on NVIDIA GPUs. What does it mean in terms of the format, right? Like, what happens when you get the model trained on NVIDIA GPU and you need to convert it to something like an AMD device?
Yeah. So in general, it's kind of like, let's say, like in theory, the output of the training is sort of like the model weights, and the model weights can run on any hardware seamlessly. Like the model weights themselves actually don't sort of like care on which hardware they go. The question is just like how optimized is the code that you actually then use to run those ways. And if you run, like if you've written your training script for like NVIDIA hardware, most likely then you're gonna have your inference code also be optimized for NVIDIA hardware. So kind of like, and that's the mind shift that you have to do. It's like, okay, if you want to now run it on AMD hardware, you have to basically rewrite your inference code to be optimized for that type of hardware. And that's kind of like the work you have to do if you want to move these things around.
And how do you know what to do then? Like,
yeah. I mean, yeah. So in general, kind of like hopefully for application developers, this is something like they don't have to think about too much.
Yes.
Like you most likely use different libraries that already come with like pre-packed kernels for different type of hardware, and you can leverage those. But yeah, you just need to know, like, ultimately, if you want to do it yourself, you have to have very intimate knowledge of like the hardware itself that you're going to run it on, and hopefully that's something like that can be left to people that actually work with the thing and they can write libraries which then like application level people can use.
So I'm very curious about open source hardware, right? And like currently we have this dichotomy, software world is taken over by open source, But in hardware, we have CUDA, right, which is closed source. And, from my friends in NVIDIA, it's like 30 levels of legacy code, like all the way down. And I'm very surprised that some of my, NVIDIA folks are telling me like CUDA is going to go away eventually. Although now it seems like it's there forever.
Yeah.
And so there is, talk of basically CUDA going away at some point. So what do you think of this model? Like, first of all, Hugging Face is firmly on the side of open source.
Yeah.
Right. So why not like support RISC-V open source hardware all the way? Like, why don't we see more open source hardware coming up, which is well documented and like will let folks like you do much better job in optimizing inference?
Yeah, that's a very good question. It's kind of like, I think actually I'm not a hardware guy, so I'm gonna take my take. But there's probably people who know a lot more about this than I do. But I think in general, hardware is just so much more difficult than software. Software has a faster iteration cycle. You can push code out. It's a lot easier to say like, oh, here's my, I'm just gonna open source this repo on GitHub. Give me feedback. Let's start iterating. Versus sort of like, let's say you and I start building out our RISC-V cores for AI. I mean, we need to have, the designs, taking out the chips and everything. That's like, it requires a lot more capital upfront. The iteration cycles are just so much slower. And I think kind of like currently we're in a position where like NVIDIA hardware and the kind of like software, like everyone uses CUDA, everything's optimized for that. So we're kind of like stuck in that. And it's very hard to like, people are trying to push for new things. But that means that you also have to kind of like rewrite a lot of the existing stack to catch up with that. And that's a lot of work to do. So it's like we're seeing a lot of new things popping up, like TensorTorrent is something we spoke about earlier, but it's like a new, very interesting solution. And their software stack is like completely open source.
Yes.
But it takes time, and we'll have to see like if something like that emerges as a like viable competitor in terms of performance, in terms of like economics to NVIDIA. Hopefully that will. But currently we're still kind of like stuck with the paradigm of yesterday.
Which is, by the way, super cool because, I've seen them present at FOSDEM. And, folks who were doing this for a long time, remember what transputer architecture was like this, like transputers with this, right, multiple mesh in, I think, 80s or 90s, right? So when computers are very weak. And so so like a lot of this mesh computational networks were thought about early, but then people forgot about them. Then we got like this massive GPU, and now we're back at like this amazing mesh. So like as a guy who does inference, I am curious, right? So you played with AMD devices, like maybe with the TensorTorrent. Do you have a feeling that they can unseat NVIDIA, they can compete, can be an alternative at some point?
Yeah, I mean, I think hopefully, I would definitely hope for them to like be more of a viable option. I think currently it's really hard to say. And a lot of it comes down also sort of like the community. I think it's not gonna be like necessarily like one person who's able to like shift the masses. Like you need a lot of people tinkering with these devices and playing around with them. The company's actually integrating that feedback to actually gain that momentum. But I do hope that we see these things like take more of a market share.
And we talked about this earlier. So at FOSDEM was this low-level AI hacking room, and there was a lot of people who basically found that they can take an open source model and they can quantize it and they can do fun stuff with it and they can try to run it on some new architecture like TensorTorrent or even microcontroller. And I guess like Hugging Face should be the home for them, right? Like you guys should be embracing them. So I wonder like what the community can do to enable more people like that to write more open source code for these new architectures, right? Do you think that this is something that like each community can join, right, to make all this stuff run better, and then we increase the range of devices which are available to everybody for AI and bring down the prices and increase adoption of AI?
Yeah, that's a good question. I actually don't have like a single good answer in that sense. But I think like we for example, we have people working on, for example, the Llama CPP project, which is a really interesting one, kind of like getting like actually like pretty good quantized LLMs run on different types of like more diverse hardware. And I think like projects like these, I think I'm like super excited when I see these go around. Because they actually show that you can do it in a different way, and you can kind of like almost rebuild the stack from ground up, like in the application levels, like from the ground up, and it totally works, and people are excited about it.
Yeah, Roman Shapochnik, who ran the dev room, he gave a talk at a fringe event called plumbers. His talk was on that Plumber CPP is all you need.
Yeah. Yeah.
So on this, all you need that test. And I felt like this is really interesting, right? Like this is really cool, and you can host your own model, right? And you don't need to go out to OpenAI and ask it questions, right? Which to me sounds very cool. Well, this is great. So, like, we're here at the beginning of the year. Like, what are you excited about with this coming year? What do you guys want to build? The Hugging Face, what's like most fun for you?
For me, most fun. Actually, I haven't thought about it too much. I think in general, like what I'd like to see is more like stability around the whole field, especially when it comes to inference, like converging more towards like standards, makes things easier to host and more kind of like easy to swap pieces out. But in general, I think we're very much still like at early days, like test and compute scaling. These things are like completely new paradigms that have come up, are like super promising now. I also like sort of like the idea of models like getting smaller and smaller while still being like super capable. You can see like, for example, we have a wonderful team at Hugging Face working on like the small LM, where they can see sort of like on benchmarks, you can see that small models actually like beat like a considerably larger model from like one year back. The difference in size versus capability is quite drastic. So that's something definitely I'm excited. Like I want to be able to run LLMs on my phone, my laptop, 24/7, like have it fully integrated.
This sounds like you're a real software engineer because you want stability, you want standardization, right? So I've been in the software engineering discipline, right? And this is often lacking in AI, right? People who write Python in the notebooks and don't care about this, right? Like they're data scientists, but like software engineers behind the scenes should bring high quality performance, uniformity, right? So this is great.
Yeah, precisely. Unified API, what's the protocol?
Exactly.
Kind of like follow it.
Exactly. No, this is great. This sounds like you guys are making software engineering discipline out of it, which I think will benefit everybody in the field. So thank you, Eric. This was great, and thanks for hosting me here at Hugging Face.
Yeah, no, it was a pleasure. Thanks for coming by.